Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 8, 2026, just yesterday. It introduces a video generation framework that uses visual prompts to augment robot training data, boosting the success rate of the Pi-0 model from about 17% to 29% in simulations. The paper is titled RoboVIP, Multi-View Video Generation with Visual Identity Prompting Augments Robot Manipulation. And as we'll see later, the system achieves even more dramatic improvements in real-world cluttered environments. And for those interested in the implementation, the authors have shared their code on GitHub. Alright, Figure 1 illustrates the complete three-stage workflow. On the left, the data curation phase segments the robot and objects from real videos, while simultaneously collecting a visual identity pool of diverse items to serve as prompts. In the top right, the RoboVIP model uses these inputs. It takes a specific visual prompt, like a bottle image, and generates a synthetic video where that new object is realistically inserted into the scene. Finally, the bottom right shows how this augmented data combines with real demonstrations to train the vision language action policy. So zooming into that curation process, Figure 2 details the segmentation pipeline used to prepare the training data. At the top, the system performs keyframe detection triggered by the gripper's action. It uses the robot's hardware signal to pinpoint the exact window where interaction happens. Below, the workflow splits into two streams. A video reasoning model called Cosmos Reason 1 first names the objects, generating labels like bowl or cube. These labels guide the central block, where an open vocabulary model called EVF-SAM isolates both the robot arm and the target object. Finally, on the right, SAM2 propagates these masks across the video to merge them for training. With the data prepared, Figure 3 lays out the actual video diffusion architecture. At the bottom, notice the three conditioning inputs: the noisy video, latents on the left, the segmented video masks, which enforce structural consistency, and the visual identity prompts that define the object's look. To the far right, a structured text prompt provides scene context. Moving up, the colors highlight the training strategy. The Patchify layer, in pink, is fully fine-tuned to handle these new inputs, while the massive diffusion transformer in orange uses low-rank adaptation. This allows the model to learn new controls without losing its original generation capabilities. Now, Figure 4 breaks down how the system builds that crucial visual identity pool from large-scale datasets. It starts at the top with raw multi-view images, which pass through a panoptic segmentation model to isolate every element in the scene. In the middle rows, the pipeline filters these segments to keep only manipulable items, while applying strict quality checks to reject blurry or partial objects. Finally, at the bottom, the approved items are randomly resized and packed into a single conditioning frame, allowing the model to learn from multiple objects efficiently. Okay, having built the pool, Table 2 evaluates how well the video generation actually works compared to state-of-the-art baselines like Cosmos and RoboEngine. The results show a clear advantage in video quality. For instance, look at the F versus D column, which measures the Frichet video distance, a standard metric where lower scores indicate more realistic temporal motion. RoboVIP scores a low 138, drastically outperforming RoboEngine score of nearly 1800. Crucially, the last column, M versus Matte, tracks multi-view consistency by counting matching points between camera angles. Here, the model achieves over 2200 matches, showing it maintains superior spatial coherence across different views. Well, having confirmed the video quality, Table 1 shows how this translates to robot performance in the simpler ENV simulator. The table is split into two blocks. The top evaluates the Octo model, while the bottom looks at the stronger Pi-0 policy. In the top section, training Octo with RoboVIP and identity prompting achieves 18.5% success, beating the 12.8% baseline. The gains are even larger for Pi-0 below, where success jumps from roughly 17% to 29%. Wrapping up, two takeaways stand out. RoboVIP proves that generative video augmentation can reliably scale robot learning by solving multi-view consistency. And second, this synthetic data translates to real-world robustness, turning failed baselines into successful policies, even in cluttered scenes. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.